Welcome back to our review of possible exam questions for rational expressions. Here we have a rational expression, which is one polynomial divided by another one, and that's times another polynomial divided by another one. They want us to express this in simplest form. When you're thinking simplest form, first thing that should come to your mind is, can any of these things be factored? Can you pull something out and can you cancel something? So I'm going to take a look at this term here first. The top is x squared plus 6x. Well, that is definitely has something in it. We could take an x out and make this an x plus 6. So there's a little bit of a factoring we can do up there. And then we want to do the bottom. So the bottom here is this. 2x squared plus 15x. 2x squared plus 15x plus 27. Is there anything we can factor here? Well, try this first. Try this method over here. You're going to need a 2x and you're going to need an x. Everything's positive. So everything's going to have to be positive. These things are locked in. There's no choice in that if it's going to factor nicely and cancel. If it factors with fractions or with roots or something, then it won't cancel anything, and it's not useful to us in making it the simplest form. So this would be necessary if you're going to have actual whole numbers and not fractions or something like that. So if this is the case, this would be 2x squared. What would you need over here? Well, to get this number over here, you're going to need something that multiplies together to get you 27. You can't use 27 and 1. That would make make the cross term far too big for this. So what else are we left with? 27 is 3 times 3 times 3. So it could be 9 and 3. Where do we put the 9 though? Let's try putting the 9 here and the 3 here. This gives us our 27 at the end. The cross terms are 9x plus 6x. That's 15x. It worked the first time. So this whole thing is going to replace this. And this factored is going to replace this. I'm going to write that out over here so we have it nice and clear as we work on the next one. Okay, I have rewritten this over here, but I've just rewritten the factored form. So this top thing over here, I've rewritten as a factored form here. This bottom one, which we've factored over here, I've rewritten as the factored form. Hopefully that will allow us to do some cancellations. Now I'll erase this on this side since we don't need this and take care of this piece over here, which is going to be multiplied. We can put this separately or we could put it all under the same line. Why don't we just, for the sake of our own ability to follow it with our eyes better, just create one long line since we're multiplying anyway. There's nothing we can do with x plus 3. We'll just write that in there. And we happen to notice there's an x plus 3 down there too. That's very convenient. Now this here, this looks like a difference of squares. A difference of squares is like a squared minus b squared, which factors out to a plus b times a minus b. Because the first term is a squared, the second term is minus b squared. The cross terms are ab and minus ab, and they cancel each other, so there's just 2 left over. This is a very important thing to be able to see quite quickly when there's one thing squared minus another thing squared. This is x squared, this is 6 squared. So this in the bottom will become x plus 6 times x minus 6. That's these 2 terms. This is this here. Now we have everything factored. Most of it factored really nicely. So let's see if we can cancel some terms here. Well, we have an x plus 6 here. That cancels with this term. We have an x plus 3 here. That cancels with that term. So what are we left with? Always be careful. You have an x there divided by 2x plus 9 times x minus 6. There, this is all factored and expressed in simplest terms. If you're trying to find the non-permissible forms, which would be one more step to take, you wouldn't use this because here you've already eliminated some. You would use these factored pieces. You could use these up here, but it's hard to see. You could use these factored ones to realize you can't have x be equal plus or minus 6, minus 3, or whatever this is over here. 2x plus 9 equals 0. X equals minus 9 over 2. These would be the non-permissible values for this one, but we're not asked to find that in this case. Just the factored form. Hope that helps. I'll see you in the next video. Bye-bye.